Good evening, everyone. I am Shyam, one of the TAQELAH volunteer, and thank you for attending this year's first webinar. First of all, I would like to thank Applitus for continuing the sponsorship. And today we have Venkat Ramakrishnan with us, and Venkat going to talk about modern software testing best practices. So Venkat is a software testing technology consultant focusing on logistic and supply chain industry. Venkat has 30 years of experience in information technology and 28 years of experience in software testing. Venkat contributes regularly to software testing industry through talks, blogs, and social media engagement. Venkat is the lead organizer for Ministry of Testing Bangalore chapter. In free time, Venkat enjoys writing, podcasting, programming, singing, long walks, and cooking. Hello, Venkat. Welcome to the stage.
Hey, thanks a lot for the invite, and I'm pretty excited to present at TAQELAH, Singapore. How do you pronounce it? TAQELAH, right?
Yes, it's TAQELAH.
All right. So, welcome everyone to the show, and I hope that you are all able to see the slides.
You can type yes on the chat window if you see the slides.
Okay, cool. Thank you so much for the response. So, welcome to my talk on modern software testing best practices at TAQELAH, Singapore. I welcome you all cordially to this session. It's a pleasure to present here. My name is Venkat Ramakrishnan, and I'm a software testing technologist consultant based in Bangalore, India. I consult primarily for logistics and supply chain companies as a vertical, helping them in their digital transformation journey. My social media handles are provided in the slide. My YouTube channel is Software Testing and Quality Talks. If you just search for that keyword, you'll be able to find that in Google, which has podcasts and talks with practitioners and industry experts on various aspects of software testing. I would encourage you to subscribe to my channel, where there are many videos on many aspects of software testing and quality. I'm pretty active in Twitter too, at FlyVenkat. You can also find me at my homepage, venkatramakrishnan.com. So a little bit about myself. I started my career in software testing back in 1994 and have been engaged with the software testing since then. I consult organizations on better ways to do testing using best of the breed methodologies, techniques, and practices. I also develop using C and Python and take part in TDD and Ensemble programming meetups. My objective in doing this talk is to create some awareness about the best practices in modern software testing. Software testing has gone through a lot of changes, but I would say the essence of testing remains the same, which is validation and verification. That said, the practices that we do have always been changing towards quick delivery to the customers. Some housekeeping notes. This talk is going to be for around 30 to 40 minutes. If you have any questions during the talk, you can ask them in the chat section. We will spend some dedicated time for Q&A at the end of the talk. While you are listening to me, I would request you to place yourselves in the environment where there are no disturbances like notifications, mobile calls, social media, etc., so that you could get the most out of what is being shared. Okay, let's get started. I'm moving on to the next slide now. Let's first look at DevOps and software testing in DevOps, because DevOps is arguably the focal point of software development process coupled with CI/CD. There is a lot of discussion going on best practices in continuous integration, continuous delivery, deployment, service level objectives, etc. Site reliability engineering accompanies DevOps in handling customer issues helped by production observability. I have depicted the DevOps symbol right there. which has been around for almost a decade now. The main focus of DevOps is to achieve agility by avoiding the handover hiccups between development and operations. While the methods and tools around that objective has achieved significant success, the representation of software testing in this picture is inadequate. As you can see, software testing is depicted only as a phase post-code between build and release. But software testing is not just that. Software testing is the process of validation and verification of both the artifacts as well as the developed software. Software testing happens in all phases of software development, from requirements to production. The objective of software testing is to make sure that the software that is being developed is doing the right things, which is validation, as well as doing things right, which is verification. So the idea of having a dedicated phase as software testing in the DevOps after code is done is not correct. It should be renamed as postcode testing or something like that in the diagram. Just wanted to point out that before we delve into other aspects of software testing. So then that brings us the question of why and how software testers get involved in all the phases. Let's look at what the software tester does. At the first place, to appreciate this better, we need to understand the key qualities of a software tester, which does not change over years or change of framework or methodology. I will come up with 3 key qualities of software testers that make them as great software testers. They are attention to detail, big picture thinking, and curiosity to learn. There are other aspects like critical thinking, but these 3 are the basic fundamental elements over which other attributes can be built. Then you may ask, if a developer has all these qualities, what is the need for a software tester? Well, experience shows that a fresh set of eyes other than the developer eyes is required in detecting issues. Is this always true for all scenarios? Maybe not, but it is true for most of the scenarios. We need to be careful while a decision is made about developers themselves taking care of testing. Today's software is pretty complex because of many reasons: dependencies, attributes like performance, security, usability, accessibility, functional correctness, etc. And deployment infrastructure also, because of cloud native scenarios and communication between software modules. It will not be possible for just the developers to do validation and verification, to foresee all issues that could occur. And that's why fresh set of eyes, which is not buried in the code and the frameworks, is required. Now that we have laid the foundation of why software testers are needed, let's look into the challenges in today's organizations. The top 2 challenges are software testers are proactively not getting engaged in all phases of software testing and ask the relevant questions. And software testers are not possessing the technical and soft skills to have conversations with various teams like business analysts, development, operations, and SREs. These challenges may be individual or organization dependent. So testers have to actively hone their technical skills and soft skills and actively engage in all phases of software development, not just the post-code testing phase. 3 other problems that I see are organizational. 1, the organizational culture does not let the testers to take initiative and engage in all phases of software development. For example, a performance test engineer is not allowed to take part in requirements elicitation session where the test engineer can give their valuable inputs. The second issue is trying to remove the human testing altogether from postcode, saying that automated scripts will take care of it. This is a very bad lack of judgment. Postcode software has several factors to consider: integration, deployment, system, and solution tests, which need human analysis and intervention. The tests run will depend on the context, and so it would be a mistake to run the same set of automated checks every time. Also note that based on the context, a tester might come up with additional tests which are not part of the automation suite. Blindly relying on the automation suite and getting rid of the human analysis and testing is a big mistake. But unfortunately, this is what is happening in companies today, and we need to educate the engineering leaders to make them prevent this from happening. The third issue is delineating detailed testing and regression, and concluding that all regression can be automated and removing the human effort. Note that during the process of detailed testing, there might be regression involved, which could be done by humans or by automation. And while doing regression, there will be a need for additional testing done by humans to make sure that additional test scenarios are covered, which are not part of the existing automated tests. So a strong delineation between detailed testing and regression is not correct. Testing is a mix of both, depending on the context. I want to spend a couple of minutes on the names of the roles that software testers take these days. Traditionally, there were two prevalent positions, one as quality assurance engineer and the other one as software tester. Today, we have multiple. We have quality engineer, quality analyst, quality assurance engineer, adept, software tester, and so on. Although the organizations have renamed the roles as they want it for their organization, the responsibility of the role is the same, which is software testing, although people waste a whole lot of time arguing about these titles and responsibilities. Let's move on to the requirements phase and see how software testers can contribute here. My goal as a software tester is to get the most bang on my buck on my software testing efforts. You might then think that once the code is developed, that's the place most of my efforts would be in. That's not correct. Studies have been done on where the most defects occur in software development process, and surprise, surprise, it is in the requirements phase. Around 65% of the defects happen in the requirements phase. Why is this the case? While we communicate with the business, we tend to assume or misunderstand what they want and build something that they don't need. If we prevent this from happening, significant cost and effort savings can be realized. Also, in a dynamically evolving product, requirements do change. And when the changes happen, it's important to keep the changes documented. There are several facets of the product that get affected because of requirements change. Project plan could change, constraints could change, architecture, coding languages, dependencies between the various modules, performance, security, deployment considerations, infrastructure, etc. If we don't keep track of this, there will be defects. In order to address the assumptions, misunderstandings, and changing requirements, it's important to have a framework that involves participation of all key stakeholders. Typically, the business, the product owner, the business analyst, the developers, and the testers. The framework should facilitate use case examples, document them, and have an automation component to verify if the requirements are met by the software. The built software in an iterative fashion would also be available for the customer to use and provide their feedback so that the feedback can become the seeds for further conversations. Behavior-driven development, BDD, is one such framework which facilitates conversations and come up with examples, documenting them into scenarios and automating the expectations as tests. The scenarios are stored in a file. The scenarios are written in Gherkin format. There are several language backends available in major programming languages like Java and Python for automation of scenarios. The key advantage of BDD is having the business as part of the conversations that define the requirements. The scenarios are written in a user-friendly language that's easily understandable by all stakeholders. And note that any changes to the scenarios will trigger a run of automation to check if the software still behaves as expected after the requirements change. This also serves as a requirements traceability mechanism. Testers play a key role in these interactions in bringing out the issues and the blind spots that others are not able to see. Testers should be included as stakeholders in the requirements discussions and should not be left out. A common practice seen in organizations is that product owners and the business analysts interact with the business, and then they convey the details gathered to the development, and then the development convey them to testers. What's wrong with this scenario is that there are multiple handovers of information involved. And during every handover, there is a very strong possibility of requirements being not communicated correctly or being misunderstood. When discussions happen with the business and requirements are being documented, all the stakeholders should be present, including the testers, so that miscommunication or misunderstanding of the requirements can be prevented. Let's move on to the next stage, which is the architecture. Let's dwell into the architectural aspects of software development. Whether you call it as your goal or your requirements, people have been trying to play around with these two words to signify that the architecture is not important, because they say that it keeps changing rapidly. But that narrative does not convince me personally. To build something of value in a time frame at a projected cost, you need to plan the architecture. If there are small tactical changes in the overall plan or the architecture, then we deal with them as we go by. But if there are big changes in the architecture, then we got to replan everything, the resources, budget, and the timelines. Whether you formally do a renegotiation through a contract or do it informally with your customer, it doesn't matter. Change is change, and it affects things. When there are changes, as a software tester, I need to assess the change and find out the changes in dependencies and all the aspects again. The architecture can be in the CI/CD pipeline as a representative diagram, so that any change to architecture automatically kicks off the checks in the pipeline to make sure that the implementation can be changed wherever required. If you are not already familiar, there is a model called C4 for architecture, which is for visualizing the architecture. I have provided the link to it in the slide. Take a look when you get a chance. As software testers, we need to insist on having an architecture diagram so that we can visually see the system and how the changes affect the system. The responsibility of the software tester is heavy when architecture is being analyzed and being changed, because they need to be in the lookout for all the stuff that gets affected because of the change. If you really want to prevent defects before code, then requirements, architecture, and the design are the phases where a significant amount of defects can be prevented. Let's move on to the coding stage. So gone are the days when software testers did just the black box testing. Today, software testers need to be aware of the coding languages in which the product is built. Not just reading the code and white box testing, but they need to be well versed with the paradigm used, whether the language used is a functional or object-oriented or a procedural language. They also need to be well versed with the design patterns so that they can suggest redesigning with effective design patterns while developing and refactoring the code. In addition to this, software testers also need to prepare the test charters or the test plans and the test cases in advance so that they can bring these notes when code is being developed, so that code can be developed taking into consideration those test cases upfront. Another important factor for testers to consider is the requirements traceability while the code is being developed. With the use of frameworks like BDD or other traditional methods of traceability, testers should make sure that the requirements are sufficiently covered on various aspects. Software testers should have access to code so that they can monitor changes to code. They should be part of the team that's intimated when there is a change in the code. This will help software testers getting alerted when there are changes, which they will review. In other words, if the software testers get to know about changes only during post-code testing, then that defeats the purpose of preventing defects while the code is being written. Hence, software testers should be considered as co-owners of the code, although they could have restricted privileges or read-only privileges of the code. Two methods are being practiced for testers to take part during the coding stages. One is pair programming, and the other one is mob or ensemble programming. If you can write code as well as test, then you can do pair programming as a software tester. If you are a dedicated tester, you can be a general tester or a tester specializing in performance, security, etc. Then you can take part in ensemble programming. Both pair programming and ensemble programming happen when the code is being written. Testers should take part in test-driven development or TDD. In pair programming, software tester can sit with the developer looking at the code as well as write the code. There is a limit of 25 minutes per session with 5 to 10 minutes break in between based on a technique called Pomodoro. This practice provides opportunities for enough thought process to be put in these sessions for developing code. The one restriction, though, is that only 2 people can be involved in a session, and hence the session may not be as effective as ensemble programming session, where multiple experts can take part at the same time. Also, you need to develop as well as test to take part in pair programming. In either of these cases, the contributions of software tester in looking at the code from various angles and providing their inputs is valuable. It goes without saying that software tester should be knowledgeable enough and prepared well for taking part in these sessions for their inputs to be valuable to the team. Note that I'm not going to share the resources on pair programming, ensemble programming, TDD, etc. And I'm going to leave them as an exercise to you after this talk is over. And once you do the research, and you can ask questions to me through Twitter or in YouTube if you have any doubts or need clarifications on any of this. Now let's look at postcode testing, which used to be called as software testing and marked as software testing in DevOps. Even as software testers get engaged in the pre-code stages of software development, one cannot undermine the importance of software testing after the code is done. There are multiple aspects that needs to be tested after the code is ready. Functionality, integration, environment, deployment, infrastructure, business and industry-focused usability aspects, system and solution level tests, etc. Of late, there have been arguments in the industry that if one automates all the tests to test the code, then there is no need for non-machine human-done testing. This cannot be farther from the truth. Testing is a learning process in which the team learns about the behavior of the software and then validates and verifies if that behavior is appropriate for the customer requirements. While testing, the tester may need to branch out, explore more areas based on the context of testing. As required, the tester might choose to run automated checks for the verifications that they would like to perform. And note that these are only an aid to testing, not the testing in itself. The human analysis and intelligence is absolutely irreplaceable, not only for deciding the right test to run, but also coming up with a new test scenarios based on the context. What is being specifically called out as exploratory testing is part and parcel of testing and have been done all these decades, and there's nothing new or fancy about it. It should not also be used as a fancy term to cut down on the amount of testing that needs to be done post-code just for the sake of quickly delivering the software to the customer, which seems to be the intent these days. We'll now look at the build, release, deploy, and operational monitor stages. We are done with postcode testing, so our responsibility as software testers is over? No, not in the modern software testing environments. The responsibility lies before, during, and after deployment and in production too. How are we going to deploy? What kind of infrastructure we are going to use? Reviewing the infrastructure configuration code are all part and parcel of analysis that the software testers need to do to make sure that nothing is broken. If selective features are being released to a few beta customers, testers need to review the plan on the feature flags, which customers are getting what features, what are the configuration and infrastructure plans for blue-green deployment, what are the mitigation plans if things go terribly wrong in the beta release, etc. Testers need to be familiar with feature flag tools. Another important thing that the software testers need to pay attention are the service level objectives and the error budgets. What is acceptable, what is not, and be in sync with the SREs if the thresholds are within control. Let's talk about debugging issues in production. So new tools have come up that trace the system state variables in the form of JSON and keep updating the system state in columnar NoSQL databases. This new approach is important because hard coding metrics that are fixed or relying on the gut feeling of the experts in the team don't work anymore in the production because of the distributed architecture of microservices. Software testers thus need to be well versed with these new age tools so that they are able to debug issues in the production when required. Let's also take a moment to talk about the business motivation behind continuous integration and continuous delivery. Why do we need continuous delivery at all? Because we need fast fixes and fast deliveries to the customer. Fast fixes because there are customers who are getting affected because of the defects or the outage, which is loss of business to the customer. In many cases, the fix is needed in a matter of minutes. I would even dare say in seconds. The key performance metric that customers look forward to is reducing mean time to recover, MTTR. By constantly aiming towards reducing MTTR further and further, we aim to reduce the outage time for customers. Let's talk a bit about the commits that happen to the trunk and software testers' responsibility on testing these commits. Of late, there are calls for committing daily to make sure that developers have something to commit, which is to emulate big companies where multiple commits happen on a daily basis. Let's take a step back to see why this commit ask comes to being at the first place. Instead of doing one big commit of a large module, which places a significant effort on everyone, including the testers, to validate and verify it, which is also a risk for the customers, because many things can go wrong in a large commit. It makes sense to break the large module into smaller modules and commit in smaller chunks. That way, it is easier to develop, test, release, deploy, and manage the software in production. Let's look at testing the commits to the trunk. So when commits are happening to the trunk, it puts a lot of responsibility on testers' shoulders, because the integration of the latest commit should work well with the already integrated code. One may argue that they have done their fair share of testing in their local machine before committing to the trunk, but there are always surprises. Software testers need to analyze the changes in the commits to see how it would affect the already existing code, and select relevant test scenarios and test cases to check if that commit works well for its own functionality, as well as working well with the other functionality that's already integrated. All right, that brings us to the end of this presentation. Thank you for staying engaged and patiently listening to my rant on modern software testing best practices. A huge thanks to all of you for attending this session, and to the wonderful organizers for inviting me for this webinar. I would like to take this opportunity to express my deep gratitude to all the software testing practitioners who are working tirelessly to make sure that the software that they are delivering is of highest quality. Again, all my social coordinates are listed in the slide. Feel free to get in touch with me by any means if you have a question in software testing or the software tools involved in the various phases of software development. With that, I would like to open the floor for questions. Thank you.
Hey, thank you, Venkat, for this amazing talk. A lot of insights. We can move to the Q&A session. The first question is from Nidesh Lane. Nidesh is asking, how do you manage training related things in your team? In this fast-paced agile development, requirements can come to check performance testing, security testing, etc. But members may not be well versed with this. So how you make sure that in the team all members know non-functional test as well?
Very great question. The answer is it really depends on the context. I agree that things change very, very fast. But that's the price we are paying for faster delivery and deployment to the customers. So I would say not to get overwhelmed with the amount of information overload on a daily basis. It is best to have a mind map of a plan of what is required, what is the tech stack that we are dealing with at any point of time, and stick to that mind map and be focused and try to learn those things which is important for the tech stack, and be well versed with those areas. Of course, things change. We'll have to revise the strategy, but I hope that, as I said in the architecture section, if things change too much, then obviously there will be repercussions. There will be consequences of the changes, because you cannot make changes just like that. It will have an impact on the resources, the budget, the talent, the learning curve, and everything. So hopefully there won't be much of those kind of big changes, but there'll be small changes here and there which we have to handle tactically. So as I said, using a mind map of your tech stack and focusing only on those areas for a particular project helps a lot. Personally, I am also using mind map to keep myself focused, because I am daily bombarded with so much of information from requirements to production, which I need to manage. And so the one method that I use is using mind maps, which helps me a lot. And every month I have a learning target. I stick to the learning target as to what I should learn in that particular month. And I also have a goal of either finishing a certification or doing some kind of exercises and being hands-on. This especially with the programming languages like design patterns and things like that, I try to familiarize myself with these exercises or certifications. So yes, this is a constant challenge. Learning is a constant challenge in IT industry, and we cannot avoid it, and especially in the agile environment. Thank you for the question.
Cool. We can move to the next one. So Ravi Natarajan is asking, it is quite often is management issues rather than ours. Still QA are engaged during requirement stage. Product owners don't include us as they feel that we are necessary and the struggle is ongoing.
Yeah, as I said, this is a problem. We have to convince the engineering leaders to make sure that they include QA people or the testing people in the requirements analysis. As I said, the major chunk of misunderstanding happens in the requirements, and it is absolutely necessary for software testers to stay engaged at this stage. We can only work on convincing the team, doing root cause analysis of the defects, and pointing them to the engineering leadership team saying that, hey, this could have been caught in the requirements itself. You know what? The requirements was wrong. And because of that, we did all this development and testing. And today we have this problem where, it is not as per the customer expectations. So that's absolutely important to convince the engineering leaders and make them aware that so root cause analysis is very important. Follow root cause analysis, have a field in your tracking tool, defect tracking tool, and make sure that you update that why the defect happened and what stage it happened. And then do an analysis, post-mortem analysis of the project is over, and show the leadership that, hey, my 60% of the defects happened because of this. And why don't you let us take part in the requirements session? So that's the only way of going about it, to convince them.
Cool. Jumping to next one. So Ravi is asking again, how QA can upgrade their profession, any particular certification that you recommend?
A QA as such, as I mentioned in the presentation, is very large in scope. From requirements to production, you can pick any one of them as your niche. For example, you can try to pick requirements as your specialty and engage with the business analysts and the product owners and making sure the requirements are written correctly and collected correctly. If you want to do that, there are a whole bunch of business analysts related certification, which is provided by an international body. So you can take the business analyst related certification. You may not be a business analyst, but why should a software tester take a business analyst certification? Because you would like to understand what the business analysis is and what are the techniques. Only then you will be able to tell, hey, you should be taking a survey for this particular scenario, but you are doing an interview, which is totally different technique, which you can point that out to the business analysts. And so these are process level things that you can influence apart from the technical bugs. If you want to get engaged in the coding and the design part, you can learn design patterns thoroughly. As you can see, the Gang of Four has written a book on design patterns, which is a very famous book. You can learn all the 23 design patterns, become very strong on the design patterns on your chosen programming language like Java or Python or JavaScript, whatever it is. And then you can specialize in that. And for that, there are several programming language courses available everywhere. You can attend that, and you can also read the design patterns book. If you want to specialize in postcode testing, you can, of course, attend certifications like ISTQB. You can also take trainings related to artificial intelligence and machine learning courses, because that also is actually making inroads into software testing, which I spoke about in my YouTube channel. There is one of the latest videos with Adam Leon Smith that I've spoken about how software testing is getting affected by AI and machine learning. So you can do a course. In fact, ISTQB has its own course on AI and machine learning. You can attend that. If you want to get involved in deployment, infrastructure, and production, there are a whole bunch of tools available. In production, you have tools like Honeycomb, Datadog, etc. For the service level objectives, there is a whole bunch of tools available. For performance, so specialized areas like performance, security, etc., have their own bunch of concepts and tools available. So you can take any of the certifications related to performance or security. So there's a whole bunch of learning opportunities and certifications available. So you need to decide what stage you want to get engaged in. And another important thing is deciding which domain I want to work on. So this is a mistake that many software testers make, that they jump from telecom to banking to logistics and supply chain, and they keep moving the domains. Although they might be good at Java, they say I'm good at Java and my resume will show Java, but the domain that they are working will be totally different. This will be a very great challenge when you are moving in career, because you need to stick to a domain. You decide which domain you want to stick. You stick for 5 to 10 years and be in the domain. Only then you will be able to learn the nuances of that particular domain. And then only you will be able to effectively contribute. For example, if I am in banking and credit card related, I need to know the ins and outs of how the credit card system works, what are the different modules involved, etc. If I'm in SAP, I need to learn SAP thoroughly, and SAP is an ocean. If I'm in Salesforce, I have to learn Salesforce. So decide your domain first and see what kind of domain-related knowledge is required. That is one of the important certifications and learning that is required. And then you can think about what stage of product development I want to specialize in, and then do it accordingly. So I can see this as a matrix where you have rows and columns. You decide on which one and you pick that one, and then you start specializing in that. So I hope that answers that question.
Thank you, Venkat. We missed this question from Shobai Sheikh. How can I measure quality of my product? Any effective QA metrics in your opinion?
Quality is not something, in my experience, so metrics are just indicators of how the product is, as far as the quality is concerned. So if I pick a number and say that I have passed 85 metrics out of 100, it doesn't mean my software is of best quality. It's just an indication. Okay, the quality ultimately is the pleasantness and the happiness that the customer feels when using the product, which is not measurable, by the way, right? You can have indicators here and there saying that, okay, I want to use this metric to make sure that this is my quality metric, and I want to measure this and make sure that I want to have, say, only 10 defects before it goes to production. All those things are fine. Those things are just indicators to show that things are, in the right direction. But just because of the fact that you have just 10 defects and I want to go to production is not the right idea, because, software is not something like a manufactured product which you can see with your eyes. So if you are in the car industry, you will have the car that you can physically inspect and see whether the part is right and whether it is working properly. But software is not like that. You can only assess the software based on what are the outputs that are being produced. The amount that we are able to see as output is far less than what is available in the implementation. So the number of combinations we won't be able to test fully. We are just looking at one specific piece of software and trying to assure quality on that particular area. So it would be a mistake to say that my software has 0 bugs or my software is of top quality or anything like that. I wouldn't recommend any quality metrics. It totally depends on your context. It depends on your product that you're testing. You as a team come up with the best quality metrics. You talk to the developers and see, hey, what is the quality metrics that we need to use here? What are the indications that you are moving in the right direction? So you need to discuss with your team and come up with those kind of metrics. There are multiple resources available in Google. Go search for them. And there are comprehensive links which are available on quality metrics. You can go through them and pick the ones that is right for your scenario.
Okay. We have time for taking 2 more questions. So the second last question is from Kathleen. Kathleen is asking, for someone who hasn't coded, what do you suggest is the best way to start learning test automation?
Okay, obviously the best way is to learn coding. There are no-code automation tools available. I'm not saying negative about them; they are great. But the thing is, as a software tester, I wouldn't recommend them to be relied upon completely for the satisfaction I would have as a software tester, right? So if I want to feel 100% satisfied with my software testing, I would rather have it under my control. Many of these no-code testing tools or automation tools, we have no clue about how they come up with some results or how they do the analysis. And many of them are based on artificial neural networks. Artificial neural networks work on errors and significantly reduce the errors so that we achieve very less error between the expected result and the actual result as we go by. That is not the natural way humans actually do the analysis. So they are fast. I mean, I'm not saying they are not good. They are fast. They are able to figure out things in a different way, which is a totally different method. The one problem with artificial neural networks based tools is that they won't be able to reason how they come about a particular conclusion. For example, if the management comes and asks, how did you conclude that that particular module doesn't have any bugs? Or how did you make sure that this module has been tested thoroughly? They will not be able to prove data, give data to the management, saying that these are the steps I followed, these passed and these failed, and this is the way I did my testing, these are the steps I followed, and things like that. They have their own method of doing the testing. So the lack of reasoning and lack of convincing data points is a major problem with artificial neural networks based tools. If you want to learn automation, if you want to do automation, I would suggest not, I mean, these days test-driven development is being done. So you can participate in test-driven development where the tests are being written while the code is being developed itself, rather than doing the automation at the fag end after the code is developed. Okay, of course, we have to do automation there also, but if you have an opportunity to participate in TDD, then you can do this in the front stage itself. And this has multiple advantages because you can do the automation in the same language as whatever the developers are using. So the developers might be able to see your contributions, and they will be able to appreciate, and there's a very good team effort that will go on if you do that there. So of course, yes, you have to learn the programming language. If you're not a coding person, then I would suggest please learn coding. It's pretty simple. It's not difficult at all. You can start with very easy languages like Python, and you should be able to start contributing with, I mean, you have to do hands-on every day so that you are sharp in the learning and applying whatever you're learning on a day-to-day basis. If you stop applying it, then you will lose touch with it and you will forget it. So I would suggest learn and then apply that on your day-to-day work so that you can become strong in coding and automation.
Let's go to the final question. It's from Jagdeep Singh. How we choose from different test approaches like analytical, regression, averse, and methodical when we are dealing with different types of projects? Let's say an enhancement to legacy application and a new of the self application first release.
Okay, this is a very subjective question because it depends on the context. So I would suggest the questioner to ping me on Twitter or LinkedIn to get this answered in detail. But to give a short answer to this, it totally depends on the test strategy that you come up with. So the first step towards testing any product is to come up with a test strategy. So in the test strategy, you will have things like what is the approach that I'm going to take, what is the methodology I'm going to use, what are the tools that I'm going to use, what are the infrastructures that I'm going to use, what is the hardware setup looks like, what are the different software that I'm going to use. All those things will be part of my test strategy. There might be pros and cons in using tools. For example, somebody might be using Selenium, somebody might be using Cypress. What are the pros and cons? Whether the pros are more in a particular tool for my environment, for my requirements. So those kind of analysis you have to do, and that's all part of the software testing strategy. You need to have a testing strategy document which will explain all these things, which you can track. This is for your own good. I mean, it's not for showing anybody that I have done the work. It is just for your own good, doing the analysis and keeping there in the paper and following that. And that is this is the way you come up with a test strategy. And then once based on the test strategy, you decide what methodologies to use, approaches to use, and things like that.
I think that was the last question, and we can wrap up the session. Thank you so much, Venkat, for your time. That was really informative session, and thanks for all your detailed answers to each questions. So we are recording this session, and this session will be uploaded to our YouTube channel. I have pinged the YouTube handle and our other social media handles on the chat. You can follow us on there. You can follow Venkat also. It's already we already tagged Venkat on our LinkedIn and Twitter account. You can follow him there. And if you have any following up questions, please shoot the questions over the Twitter or LinkedIn. Thank you so much, guys. Thanks for your time. Bye-bye.
Thank you. Bye-bye.